Like it's the presentation, but that's how they sound. All right. Sounds like everything good is good now?
I think so.
Great. All right. My name is Sean Ward. I'm here with Rob Dew, who supports the Office of Emergency Communications, which is part of the Department of Homeland Security. Dan Hawkins is the regional coordinator from the Office of Emergency Communications, and he is here. And Dan is typically the guy that when you need a regional belly button for OEC, he's the man to go to. So, and he always comes to these. So he's always out in the field meeting with folks, and he has some great relationships across the 2 states. We're going to be presenting today on understanding public safety broadband. We've learned that as we do these presentations, we did a couple in Utah recently, we were in Maryland a couple weeks ago. We don't know how technical we're going to get in the presentation because we always kind of take the lead of the audience and the folks who are attending the training. So we may get into some weeds on certain topics, but we may keep it at a higher level on other topics. But feel free to please ask questions as we go through the session. Again, the Office of Emergency Communications has done several of these training sessions. And basically what we're trying to do is to talk to first responders, talk to IT people, talk to the leaders in the states on the different, number one, what LTE is from a technical standpoint, the growth of public safety data and how you're going to be using public safety data when the National Public Safety Broadband Network comes online, but also the differences between radio and LTE, which is they're very, very different. So we get into some of that as well. And again, ask questions as we go through this. Sorry, we're having a slight technical issue. We're trying to advance our slides, just to give us a second. Okay. All right, so today is broken up into a few key pieces. Number one, we'll talk about broadband data and public safety, how you currently use data in the field. If you don't use data in the field, that's certainly a possibility, but we'll talk about what we're seeing in other states and other agencies. Talk a little bit about documenting user requirements and how those requirements will move over to FirstNet and how they will, and we'll let Kim talk about the process she's going through with FirstNet and collecting all of this fun data from everybody across the state. Then we'll talk about the infrastructure components of LTE. Then we'll get into more specifics of an LTE network and the LTE network. So any questions on the agenda before we move forward? Kim, do you want to, does this sound?
No, and so this can be more technical or more operational, and I've shared with Sean and Rob that you guys are more operational people, and so at the point, if it becomes too technical, raise your hand and say, hey, you lost us, and we can modify on the fly to ensure that the content is relevant to you and how you are working in your communities. So we don't want it to be a waste of time where, if we get so deep on LTE engineering that it doesn't provide value to us.
So before we move forward, first of all, we have to say we're not from FirstNet, we're from the Office of Emergency Communications. We cannot speak on behalf of FirstNet. We don't speak on behalf of their timeline or anything like that. Kim is, from the state perspective, is the point of contact for
our office is the point of contact. I'm not the point of contact. But
gotcha.
yeah.
Thanks for clarifying.
Sure.
So that's the first housekeeping item. Second, let's go around and talk, have everybody report out on whether you're from fire, whether you're from police, EMS. Let's just go around the room real quick and have everybody introduce themselves. You want to start?
Doug Williams, Delta County, IT Department.
Okay.
Carl Stevens, Garfield County Emergency Communications, reporting on the Night Center, and I'm also the ESAP rep.
Steve Schroeder, High-Speed Fire, and I'm on the PSCS and CCS.
I'm John Davey. I'm the project coordinator with FirstNet Colorado.
I'm Dan Hawkins. I'm the regional coordinator for OEC for the Rocky Mountain region, 6-state region. That includes Colorado and Utah and a couple other states. Just as a matter of background, mine is primarily operational. Previous law enforcement for a number of years, statewide public safety communications management. Consulting work, working in this field 5 years with the dark side with the federal government. So.
I'm Jennifer Dismore. I'm the San Diego County Sheriff's Office and Emergency Management. I'm also the chair of the All Hazard Region. And been in emergency management for about 10 years. I'm Linda Belkey. For San Diego County Dispatch Director. I'm basically, I don't no longer dispatch, but I'm basically the management. 35 years along. Technology. I try to stay abreast. Tony Johnson, Delaware County.
We can try the people on the phone,
Yeah, you
or
want to,
they can just chat me.
okay.
Yeah, if they want to try, I don't know.
All right, does anybody on the phone want to chime in and do the roll call? Great, thank you. Next. Thank you. Next. Great, thank you. Anybody else? Nope. Okay. As we mentioned, we're from the Office of Emergency Communications. Office of Emergency Communications is part of the Department of Homeland Security. OEC's been around close to 10 years now. With interoperability issues being so prevalent, especially in land mobile radio, over the last 20, 30 years, it was really nice to see the Office of Emergency Communications get created. OEC basically deals heavily with interoperability, voice communications, but over the last couple of years has started to look into the mobile data side, the site hardening side, and the resiliency side of communications, and also the 911 side. So all of these pieces of technologies are coming together in the field, and OEC has taken the lead here to understand them, understand all of the governance issues that reside with this, the technology issues, the procedural issues, and the training issues around all of this. So it sounds like a lot of folks in here are from the 911 PSAP side. So we were just talking earlier that the PSAP is becoming kind of the center point at the local level for all of these technologies, because what we're hearing, what we heard in Maryland just a couple of weeks ago, is that the commanders in the PSAP and the leads in the PSAP are having to deal with lots of different issues. Whether it's requests from the public for 911 data, requests from the public on body cams and video and things like that, or requests from the media, the PSAP is becoming the center point of that. So you all, I'm sure, are starting to see that if you haven't seen it already. But with all the different technologies that support public safety, we're seeing the PSAP as kind of the center. So today's Office of Emergency Communications, we do three primary things: planning and preparedness. I know, Kim, you said you worked on the SCIP plan. We've done SCIP plans and updates in all the states and territories. We developed a National Emergency Communications Plan, which is kind of like the Bible for emergency communications priorities for DHS. And most of that NECP is focused on state and local issues. OEC prides itself on being able to focus heavily on state and local issues and all of the governance and procedural issues that affect you all at a state and local agency, and all of the issues you have to deal with when you respond to these incidents. Coordination, Dan is one of the key points of coordination here. We have regional coordinators in all the 10 regions, aligned to all the FEMA regions, correct?
Well, we call them DHS regions or GSA regions.
I got you. Okay.
OEC is not FEMA.
I'm just dating myself from the FEMA standpoint. But okay, so there are coordinators in each region. These coordinators are responsible for understanding the needs and priorities of their customers, state and local customers in that area, including the federal agencies as well. Technical assistance, which we're actually out here on technical assistance. We provide over 100 technical assistance workshops each year typically, and the SWIC of the state is the one who's the SWIC of?
Jack Cobb.
Jack Cobb. So the SWIC of the state is the one who requests technical assistance from OEC, and the technical assistance we provide can range from ComHealth training to 911 training to cyber training. You name it. We do have a catalog online if you want to go through that, and feel free to work with the SWIC if you want to make a request. And then response. OEC manages the wireless priority service, the GETS program, the Government Emergency Telecommunications Service, and also TSP, Telecommunications Service Priority. And when incidents happen and networks go down or networks are overloaded, those programs and those technologies come into play. And just recently found that during the Navy Yard event in Washington, D.C. area, the GETS and wireless priority services was heavily in that process because everything commercial systems go down. So that's one of our response services. Any questions on OEC? Yes, sir.
On the response side, I might add within OEC, the regional coordinators are designated federal emergency response officials. And that designation is for telecommunications emergencies. Essentially, in the case of a large-scale emergency or disaster, where there's impacted communications, there could be federal-level activation services to support state, local, tribal, even federal agencies to restore or supplement tactical communications. And through OEC, we support that nationally and in our individual regions.
Thanks, Dan. Okay, let's move into broadband data and public safety. One of the things that we like to focus on initially, because there is a lot of confusion in the field, even at the federal government level, on what is happening with LTE. Is LTE going to take over voice communications? Is it going to take over our? We're not going to focus on our land mobile radio networks anymore. So we use this slide to try to drive home a very important point, or the next set of slides to drive home some important points. First of all, the radio communications that you have, that your officers and firefighters wear on their belt, have in their cruisers and their fire trucks, those are sticking around for quite a while. That is the only communication system that they have now that is mission critical. So their voice communications that they use every day to call dispatch, to coordinate with each other, to respond to an incident, they're using the radios, they're using the land mobile radio network. That is mission critical. That is built to withstand, in most cases, built to withstand weather events, built to withstand, it has site hardening aligned to those LMR sites, and it can withstand either natural or man-made disasters. So right now, land mobile radio is a primary voice communications for public safety, and that is not going away. You can see the red line here shows that that's mission critical. Now, the other part of the current state is that, sorry, I was confused by the display here. If you look on the left side, all of the data that your officers and firefighters are using, unless you do have a private network, most all the data that they're using, either if they have mobile data computers in their cars, or they're using their smartphones, that's all commercial, and it's not considered mission critical. This is commercially available service. The officers and firefighters are basically just like any other user, any other citizen who has a cell phone and uses their smartphone to access the internet. They're not, your officers and firefighters are not getting any priority over the standard users now. So right now, all of the mobile data that they're doing is done over commercial networks, and it's not mission critical. And then commercial voice, any voice communications they're using that's not on their radio, that is also not mission critical. So they're using basically commercial networks that have been built out for the general public, and they also do not get priority service over those networks. The issue is currently, from a commercial standpoint, anytime you're using mobile data or using their commercial voice, they're susceptible to site outages, congestion, and coverage issues. Those coverage was built from the commercial network standpoint for basically where the population is. So when your officers and firefighters respond in the field, if they respond to an area that's very rural, they're probably not going to have very good commercial coverage. So right now, the current state is land mobile radio is the only mission critical network. The other commercial voice and data is not mission critical. So that's our current state. Now let's look at the immediate goal. And this is where FirstNet comes in. Again, we don't speak for FirstNet, but based on what we've heard, this is what's going to happen. So everybody's going to keep their land mobile radio. They're going to keep their radios. They're going to keep the networks in place. But the first goal and the initial goal for FirstNet and over the next couple of years is to make the mobile data piece mission critical. So you'll still have your radio, but that mobile data piece, once FirstNet gets built, is going to be mission critical. And I say that because they're going to ensure that the sites are hardened when they build the sites or acquire the sites. They're going to make sure that they're more resilient and also have the preemption and priority for first responders that first responders don't currently have when they're using mobile data. Everybody, any questions on that? So land mobile radio is not going away, but when FirstNet is built, the network will provide mobile data and data for first responders, and that will be mission critical. However, there's still no voice that will be mission critical for FirstNet. Now, the long-term plan, we don't know how many years this will be. Rob, chime in if you want, but the long-term plan is to have land mobile radio as mission critical, but also to have mobile data and commercial voice as mission critical. So FirstNet voice as mission critical. So hopefully, in several years, you're going to have first responders every time they push to talk, either whether it's on their radio, whether it's on a smartphone, or whether they're pushing video to a PSAP, is all going to be a mission critical framework so they can make sure it gets through what it needs to get.
Yeah, I'll just add, so there's a standards body that handles the LTE standards for the commercial world. It's called the Third Generation Partnership Program, and they're starting to put a lot of public safety functionality into the standards. They kind of start, well, you could say they started with Release 8, that was the initial release. But Release 10 was just deployed in the US. Release 11 is coming up. Release 11, and we'll talk about it a little bit in further in the presentation. But the key point is they just started working on mission critical push to talk on LTE. They just formed the standard body, the working group for that late last year. So it's going to take them a couple years to do the standards. It'll probably be 2016, 2017 before it gets written in standards. Then you have to have products come out that'll productize it. So it could be anywhere 5 years, something like that. But even when mission critical push to talk, assuming that the technology works and it deploys well on LTE, you still might not have LTE coverage in the places that you have LMR coverage now. So, we don't see the LMR networks going away for mission critical voice. It could be, no one really knows, it could be 10 years, it could be 15 years. But certainly for the next 5 to 10 years, we feel you'll be still relying on your LMR networks for mission critical voice.
Okay, let's talk a little bit about mobile data. Just by a show of hands, does anybody have first responders in this area that have mobile data computers in their cruisers? 1, 2. Okay. How long have they had them?
We've got one that's had, well, we got 2 that had for several years. One, our major sheriff's office is going.
Are you using LTE right now for data? Using like an enterprise contract with a carrier? Or
Yeah,
is it
some of them I think are still free.
okay, so it's EVDO or HSPA or something.
And what types of applications are they using? What are they doing with their computers?
They can see CAD, and they're also moving law records, in-car records, so they can in-car report.
Okay. How about you, Nick?
They have.
6.5 years.
Any
Because
other?
LTE, the cards,
Right.
ropes, access, databases.
What is coverage like? I assume they're using commercial networks. What's coverage like for them when they're responsible for that field?
For us, generally, probably way up in the North Fork, there's some spots that are weak. We have to attend extra appurtenances to bring in the signal. They'll just move to a spot where they can communicate. So it's really not too much of a, plus they're going to be putting towers reportedly up in that area soon, so you wouldn't mess it up.
One thing that the OEC did a survey, and it's still actually an open survey, but based on 1,000 submissions, mobile data survey, 59% of respondents said that data is mission critical. For many years, we looked at voice as being the mission critical piece, and it always will be, because you don't necessarily need to see video when you're calling for help. But mission critical data is becoming a mission critical item for public safety. Certainly, a lot of times it comes down to, if you haven't had it, you don't know what you're missing. But once you get it, then you feel like, I can't live without this. I can't live without seeing mug shots real time or streaming video real time. So it's becoming much more important. And I will say that we're seeing it in urban areas where the commercial networks are built out. It's becoming mission critical much more quickly than it would. Does anybody have any comments on that? Does everybody agree with that? That mission critical data is becoming mission critical? Is anybody hearing any of that from their responders?
All I know is an area where we don't have mobile data terminals, just because there's areas we don't even have radio coverage.
Right.
We're in a very mountainous. I do know that our dispatch, we're seeing more and more requests from the officers for information to be sent to them via email, so they can try and obtain as much as they can. So I can see the huge impact in the future on the data, and the need for that data to be in the vehicle. We're constantly sending mugshots.
What about smartphones? Are your agency provide smartphones to officers and responders? Anybody who does not?
That we use body cams, and then you have to store. It's huge.
So with the body worn cameras, are you going at the end of shifts and just putting them into a cage and then they're uploading it? So they're not really looking at anything real time yet. They see it
They can,
real
if I
time.
put the clients on their MDCs, they can watch it right there, but they can edit when they're out in the field and things like that.
Because we see, well, we have a slide coming up, but the general public has really moved a lot towards video. So like, Verizon in the next year, they think 70% of their traffic is going to be video. And it's not multicast video. It's not the same video stream going to everyone, and everyone's getting their own stream. And especially if you do that on the uplink from the terminal up to the tower, you can quickly sync even an LTE network. If you look at I was up in Philadelphia, and they're doing a lot of trials with body-worn cameras, and they looked at all the vendors, and they're looking at 720 PhD cameras, not 1080, but those can go from 2.2 gigabytes to 2.7 gigabytes an hour of content if you're doing it constantly. Well, if you were to stream that real time, at the low end of that, that's 5 megabits per second, and that's a very fast uplink, even on LTE. In fact, if you're at the edge of a cell's coverage in LTE, you probably won't even be able to do that. You're going to have to go shift down to SD or your standard definition video, or move closer to the cell site. So, all the applications you're using now, you may be limited by, data caps on your enterprise contracts with the carriers, or maybe you had congestion, you were competing with the public. Once we see LTE broadband for public safety starts really spreading out there, we don't see any reason why it won't go more towards video, similar to what the public's done. So there's going to be a very big data demand, but you would be the experts in your use cases to see, even if you think you have a need for video on the downlink or the uplink.
This takes money.
Yeah.
Well, we're definitely hearing in all the sessions that the procedural issues that go along with the enhancements in data and body-worn cameras, the video that you're uploading and trying to manage and store it in the cloud, you store locally. All these issues are becoming certainly a management problem for police, fire, EMS. But also, if you look at the personal BYOD side, the bring your own device side, where you have officers and firefighters who are using their own devices, you have the procedural issues there, policy issues there. How's everybody dealing with that at the local level with officers and firefighters using their own devices, potentially using them to support their job day to day?
We just have one device and they can use it professionally. We have time where we are because, we don't usually go over a lot of data because we don't have opportunities for them to go over it usually because we have sparse. But, our towns, of course, not the villages, right, they have LTE.
Yeah, they're using it every single.
Question, I presume they use those devices as telephone, not just data. Right.
Yeah.
How is that important to them? Telephone ability?
Oh, yeah, for our officers.
Yeah, I think that's the question. When we're talking mission critical voice, most typically we're alluding to push to talk.
Right.
Traditional type of one to many to one type of communications, but there's another type of voice, and that's telephone.
Right.
Maybe Kim can answer this. She may have most recent information. Is FirstNet talking about deploying telephone voice in its early rollout?
So I don't know the answer to that. I do know that FirstNet has said they plan to do voice over LTE. And I don't know by 2018, which is when they said that's when you'll first see the network, if commercially you'll see a migration to voice over LTE, and that will replace the 2G cellular voice capability. I don't know if you have any thoughts on that either, but that might be how they're supporting non-mission critical voice is voice over LTE.
Yeah, I think they would offer it. I mean, as long as you're not communicating, PII or, certain information that you would be worried about going over a commercial network that may not have the encryption that you might expect from a dedicated network. But certainly I think that they would allow you to fall back to that. I mean, they would offer it. It just wouldn't be one of these things where they can tell you it's mission critical. It's got all the built-in capability that a mission critical push to talk would have. And, VoLTE took a while to do. Verizon was talking about doing it years ago, and they finally started deploying it late last year on a couple of handsets nationwide. AT&T was deploying it in kind of cities here and there. So as Kim was saying, people are just getting used to VoLTE, and it's going to take a while, years for that migration off of circuit switch, CDMA, GSM's going 2017, but CDMA and UMTS, the 3G voice technology. Is going to take a while for people to migrate over to the VoLTE. And plus, the carriers need to actually have the VoLTE. They've got LTE coverage, but they've also got to have the VoLTE coverage matching the circuit switch coverage, which a lot of carriers have told us, in the next couple of years, they're going to try to have parity with that. Because for the carriers, it's expensive to operate all these different technologies, right? They would love to just put everything on LTE. They don't have to operate multiple technologies. But, Yeah, the public's just getting used to VoLTE, so, you know, public safety is going to take some years.
So in the initial, in some of the pilots that are going on, do those have, those just have the data piece on it? They don't have the commercial voice on it?
Yeah, and we can pass this around. This is a Sonim Android device. It's a hardened device, and they want us to do that, so I could chuck it. Right now, it's on the Wi-Fi, but we'll pass this around. It's not locked. You can just push the lock on it, and it'll open for you. But it does not do cellular voice. Currently, it's really a data device. I think as they work with the AT&T and Verizon, Sonim, the manufacturer, it will have that capability, but this device does not.
How secure is that when it comes to being an Android device?
Secure.
You know, it's got some real holes in their security.
Right. No, that has not been addressed either. This is really, the function of this device at this point is twofold. It's to show you what a hardened device would look like in the future. And then number two is to show you this device. Actually, I live in Adams County, where we have a public safety pilot network. And I can access the Adams County Public Safety private network with this device. So that's really its function today.
And so does it actually have the security built in to meet CJIS compliance?
Not in this.
Not in its
correct. Yeah, they'll be having to
Will they
address
be
that.
moving to
They'll have to
something
address
like
that. Yeah, for it to be marketed to public safety, absolutely.
Okay.
Yeah.
All
So,
right,
but
I
not
need all of this, so-
no, not in its current format.
Just
So,
thought on that, you're passing CJIS compliant data over commercial networks, and I'm probably doing it through a virtual private network, some form of encryption. That same approach would work across other types.
Okay.
Yeah, they'll have to have VPNs, and you know, when you set up VPNs and you do IPsec,
Sure.
you do IPv6, you know, then you start eating into the capacity to have the extra encryption and security. But yeah.
but that device, no, does not do any of that.
And the really, the very interesting thing about that, and we'll talk about in a couple of slides, is that has band class 14 capability. So that can actually transmit inside the band that's been given exclusively to FirstNet for public safety. And there's very few devices that have that band class right now.
I would suggest that between mission critical and not mission critical, it's great, not like point.
Right.
You see a lot of officers or agencies or whoever using their cell phone a lot for stuff that's almost mission critical.
Yeah, that's, I mean, and you know, that along with this new technology, you know, there's going to have to be concept of operations. But you're right, when officers and first responders are using their own personal smartphone, you know, unless there's identity management and different profiles in there for work versus personal, you know, I always say about this, the technology is always the easy part. It's always the policy, the governance, and the operations, and how you use that technology is a difficult part. And you don't need to tell the officer, you know, what sort of, because you can't send personally identifiable information. You shouldn't be sending that over, you know, a non-VPN, you know, on the commercial network. So, you know, there's going to be a lot of training in how first responders use this technology and what can they do on cellular voice or VoLTE voice. You know, what do they do on band class 14 data, which we're going to talk about in a minute, or the commercial side of the data, because they're going to have a phone that can access a lot of different technologies and access a lot of different networks and frequency bands. And what do they do when, and how do you make that easy for them so that they're not thinking about all that? They can be doing their job. It's going to be really, it's the operational side is really going to be the hardest part of LTE public safety, not really the technology.
One of the things we try to push at OEC is FirstNet's coming in a few years, but you're dealing with mobile data right now. You're dealing with all of these smartphone issues, procedural issues. You can't really wait until FirstNet gets here, then have to deal with all of these governance, SOP, procedural issues. So think about these issues now, like when your officers are using their personal cell phones, what are they using them for? How are you securing them? Ensuring that the identity management process is down, and also the security piece. Because we were talking earlier, if you're in a foot chase and your smartphone in the foot chase, what's your procedure? And it's their personal smartphone. You have a procedure. They have taken evidence pictures today on that smartphone. So agencies are having to deal with these things now. And OEC is trying to get folks to focus on them now so that when dealing with FirstNet coming down the line, pushing out these smartphones, you have a good runtime to deal with these things in the upper procedures and policies. I think one of the big things you see is officers, especially detectives, will use their cell phones for a good portion of what they do day to day. Because they're talking to people on the phone, making lots of phone calls. Just different. Typically, if you're in uniform and responding, your radio is your priority, but if you're following up on investigations, you're using your phone much more. Any questions on the mobile data piece? Anything anybody wants to add on their use of mobile data? What does everybody see coming in the near future, just on the commercial side? Does anybody have plans to push out more smartphones to folks with new MDCs in the cars? Anybody working through that process now?
One of the things that the sheriff's had me looking at, because we do have a limited, for lack of a better, tower coverage, for lack of a better terminology, and CAD systems can be incredibly expensive. We are looking into an alternate commercial ABL type program to where we can connect the devices to all that without having to pay the exorbitant amount program for a free agency center. So when you start looking, so I do see that, especially from a smaller agency standpoint, you're going to start seeing people reaching out more to those more cost-effective type of devices data to track on babies, especially where it's tough to find the money.
I think somebody brought up earlier, what are your citizens demanding of you? I'm going to get to this next slide. We do our after-action reports using what's called the emergency communications ecosystem. From 911, text to 911, we look at both radio and mobile data. We also look at the technologies used to push alerts out, put alerts, warnings information, but also the social media side, how citizens communicate with each other and communicate with departments during an emergency. So citizens, are much more savvy typically than we are saying, "What did you get this? Did you get my post on Twitter?" God, who are you? I don't know if we got it or not. Agencies, especially with the PSAPs, are having to deal with this. So what are you seeing from your citizens? Are they demanding change and you can't afford the change, or you can't afford the process to get to that?
I haven't noticed any of that. I know that, they do rely on code reds. And of course, it's always worse when the citizen outcry is more, is much greater than when somebody does something right. But I do know that our citizens really do rely heavily on those two types of communication.
Any officers tweeting from the field during response?
We have the sheriff uploads videos to YouTube, so.
Okay. Well, I brought up the ecosystem. It can be kind of a confusing graphic, but if you look at, I'm sure the pointer is working. I'm just going to.
Yeah, you can do it.
Is it working now? So we use this when we do after-action reports. Basically, it's broken into 4 segments. The right segment is the citizen communicating with the government or public safety. It's broken down into the types of technologies or systems that are used, and it's broken down into the types of information that's shared. The top segment is government to government, how public safety communicates with each other or with other government agencies using mission critical voice, backup voice, and also data. On the left side is how the government communicates with citizens. The technology used there, we break it down to outdoor warning systems, which are very basic and have been around a long time, but it's something that we often think about in the emergency communications context. Priority or proprietary notification systems, EAS, emergency alerting, you name it. And then the bottom is the citizen to citizen, how they're communicating with each other, and that includes amateur radio. We know that amateur radio is a big deal when everything else doesn't work. Amateur radio is typically still there to communicate. So this is how we look, how OEC looks at emergency communications from all these pieces. Now we don't have the time or money to focus on all these pieces. We still focus heavily on the mission critical voice and 911 and mobile data. As a public safety manager, if you're managing a PSAP or you're a commander, you have to think of all these pieces because your citizens are going to be demanding you to think about all these pieces. So this is how we kind of look at the mobile data world is growing so big. It's not just about LMR anymore. It's about all these other moving parts and all the policies and procedures around these. And then we use this Rubik's Cube graphic. You see land mobile radio, and that front piece is all the issues related to land mobile radio. On the top is mobile data and all the issues you have to deal with there. And then the right side is 911. That's OEC's focus. So all of these different issues with standards, priority, and SOPs and things like that. Any comments on this? Does it make sense? All right, so we're going to talk quickly about documenting user requirements in the consultation process. Do you want to give everybody an update on the process?
Sure. So we actually have a first pass of data due to FirstNet on September 30th. I think you're all on our newsletter list. We've been kind of bombarding agencies, asking them to participate through our Google form. We don't use the MDST. I know you guys will hit on that a little bit. We use a Google form because Colorado is a Google shop now. And we're really just seeking information on the number of users, devices, applications, kind of general information on the service plans, and then any barriers to adoption. We know cost and coverage oftentimes are the biggest barriers. And that information is going to go to FirstNet on September 30th, in addition to input on what we think Colorado's initial pass on coverage should look like for, that will inform the RFP that FirstNet has said they plan to publish at the first of the year. And then they'll be in an RFP process for pretty much all of 2016. That will not stop us from continuing to gather user requirements because I kind of consider the relationship between the states and the FirstNet, especially once the RFP gets published, as a negotiation, right? It's going to be a discussion with them about what our requirements are, and those are going to change in the next 2 years as they go to RFP and select a partner or partners. And then our requirements are going to change internally because agencies are going to change the way they do operations. Carrier coverage hopefully will improve for all of you guys in the commercial space over that time, which will impact what our coverage requirements are. So it's going to be an ongoing conversation. It's kind of the way I see it.
Great. Yeah. And when FirstNet's focusing on coverage and the way we're advising folks in the field is basically FirstNet's interested in where do you need coverage, and consider this is mobile data coverage. Where you need mobile data coverage is the first piece, and then how many users do you have? Because the number of users drive capacity and other topics as well. So how many users do you have? What are they going to be doing at those locations? So specifically, not just the standard day-to-day operational locations, but areas where you might have an event once a year, or you might have a major event like a football game or something like that. Where are you going to have a large number of users in a certain geography, and what do they need to be doing there? So I know Kim has been working with this. That's part of why she's collecting all of the data for FirstNet, is to try to drive towards what this coverage, this first draft of coverage is going to be like. So I was happy to hear somebody from the GIS side, GIS person. So one of the biggest benefits that we've seen in the field is when you have really strong people who can do the mapping and put in the different layers of coverage, and Rob will talk a lot about this in the social data as well. But the better you know your coverage requirements based on real data, the better that negotiation process is going to go that Kim alluded to, the better case you can make for why you need coverage in certain. So Rob has a couple of really cool slides that looks at social data, looks at the movement of people, either on hiking trails. I don't know what else do you have in there?
Well, when we get to it, it's basically, a lot of the census data you see is where people live and work. But you've got things like Burning Man in Nevada. You've got Manhattan's a great example. They'll say there's 3 million people there, but then it goes up over 9 million during the day. So what we tend to look at is a lot of geotag social data. So I think I'll save it when I get to there. But basically, it gives you a much better idea of where people are moving and clustering during the day. And ultimately, for public safety, their goal is protecting loss and property. So if you know where the public is most likely to be at any given time during a 24-hour period, that will help you when you look at actually your site placements to get that as close to where you see the public congregating. Or when your negotiations with FirstNet, when they pick a carrier, like say a Verizon or an AT&T or whoever is their infrastructure partner, when you look at those sites, you want to make sure those sites that they're recommending for putting the LTE public safety band class 14 equipment on aligns with where you see the public and where you see the biggest risk for life and loss of property. But we'll get into that a bit more. I just want to make one point on the commercial coverage, by the way. This is a lot of marketing stuff, so this is not necessarily guaranteeing that you're going to. We know marketing versus when you go do drive tests and you take what we call an LTE scanner and you go out and actually scan what the throughput is. It's quite a bit different in terms of coverage and capacity. So I just want to make it clear these are kind of marketing. So if you see an area where coverage isn't any good, and it also wouldn't just be LTE. This is 3G, 2G. It's all commercial mobile technologies together.
And when commercial providers are building their networks, they're looking at population primarily. But you have a very different problem to attack in this. So the more data you have, the better data you have, the better analysis you do, the better you'll be able to identify where those coverage areas are. So these are some static maps you've had in here for a while. These are your critical infrastructure. You just pulled these from some of the data we had. I'm sure you guys have many data sets on this in Google Earth. Your public safety population, how many agencies do you have, how many officers, firefighters, sworn, police officers, but also firefighters who are both volunteer and professional. You have to include all those pieces. Let me just end on the OEC tools. I know you mentioned the mobile data survey tool. I think we have about 26 or 27 states use the mobile data survey tool to collect data on the cost of commercial mobile data currently and user data and things like that. Sounds like you've moved to a different process. OEC also has CASM Next Gen, which plots right now land mobile radio locations. You can get access from your SWIC to go in, and your SWIC, I believe, has to go in and make those changes. But OEC has tools on publicsafetytools.info to help you through the process. So Rob and I are going to tag team this infrastructure components piece. Not sure where the questions will go. If they go technical, Rob can respond to them. But we just want to talk the basics of LTE. First thing we start with is always the 700 megahertz band allocation. If you look at what FirstNet has been able to get, originally the D block here was aligned to public safety, and it's 10 megahertz in the 700 megahertz band. FirstNet was able to through a lot of work on Capitol Hill, a lot of negotiations, a lot of advocacy, basically get 20 megahertz of LTE spectrum in this process, which the way we look at it is this is beachfront spectrum. This is a lot of spectrum. If you look at it from a comparative to, if you look at Verizon, what does Verizon have? 22 megahertz in 700?
Yeah, they're at 20 by 20, yeah.
Yep. Well, this is a lot of spectrum for public safety. This is a really great thing for public safety. This is why things are really looking positive for public safety to be able to use this network, because it has number one, it has the spectrum, which is always hard to get. Anything on this, Rob?
No, I think that's good. Yeah, just keep in mind, this is, when we talk about band class 14 on the uplink and downlink, it's 10 megahertz up and 10 megahertz down simultaneously. So it's a frequency division duplex system. And so we talk about band class 14, we're talking about this upper 700 megahertz, 758 to 768, 788 to 798. So that's, we talk about the design slides later on, and when we say a band class 14 site, that means like a cell site, or what they call an evolved node B and LTE. It's going to be using these channels here. And you can see the commercial carriers are, adjacent to them. So you say like a band class 13, you see is Verizon. AT&T has in band 17 and band 12. So this is very lucrative real estate to have frequency spectrum. It's very good in terms of propagation out of rural and suburban areas. It also gives you good in building penetration, assuming that the building's not made out of that green stuff that reflects 700 megahertz. But in general, it's a very prime spot. This is where all the carriers wanted to have spectrum real estate for their LTE networks.
So let's discuss the basics of the LTE network. I know we do have backup slides. If anybody wants to get into the actual wire diagrams of this, we do have those. Basically, four key components, 4 key layers. Number one, the core. This is the brains of an LTE network. Where's the core located, or where will it be located?
We've got a chart coming up about that a little bit later, but when we call the evolved packet core, like Sean said, it's kind of the brains of the network. You see here we've got user traffic and signaling, so it breaks up what they call the control and user plane, so signaling and traffic. Now, the user traffic parts of the core, most likely you want to have that distributed out to regions because that's carrying your traffic, so you want to try to offload traffic as close to the edge of the network as possible to keep your backhaul costs down. The signaling part, however, can be located a little bit further away. So we don't really know exactly how the core network for FirstNet is going to be, or a core network would be for a LTE public safety network that you deploy. You could have your own physical core components that are just for public safety, and then you share backhaul and towers with a commercial carrier. If you're doing a VoLTE, you're going to need something called an IMS core, where you may want to actually bring a little bit more of the processing further into the core. But I generally think for the purposes like here, you might have signaling core components, for example, in Denver, but you may have user traffic components, which they call a packet gateway or soft gateway, closer. So you might have one in Grand Junction if you have an internet site there. When you have these core components that handle the user traffic, ideally you'd want to locate them in network-to-network interface or data centers where there's a lot of backhaul and fiber and where carriers are. But you want to keep the user components that are carrying the traffic as farthest to the edge of the network as possible. Otherwise, you're going to have a lot of backhaul and transport costs. The signaling is a lot less of a data rate, obviously, so you can bring that, maybe all the way up to, say, for example, Denver in this area. Signaling? Yeah, that's just, so the traffic is all your data application. Signaling is basically controlling the applications, like how you get your priority, signaling to devices to do handovers between cell sites. It's basically the kind of commands of how the different components in the network are going to work. Whereas the user traffic is actually your voice call, your FTP, your video session, that sort of thing.
Second is the transport. I know people have heard about backhaul, fiber piece, or the microwave will also be included, correct, Rob?
Yeah. Hopefully Ethernet microwave.
Right, but yeah, so when you look at transport, it's basically how information gets from point A to point B. It's typically fiber, in the case of microwave will also be involved. The next two are the ones that you'll probably be most involved in. Radio access network, which is, I guess, most comparable to a LAN mobile radio network where you have sites that provide the coverage and the signaling and user traffic. And then the funnest part really is the public safety user equipment, which is what everybody's seeing. This is really what's going to be in your officer or firefighter's hands or in their cars. And that's the final piece. And that's the piece we're going to be dealing with the radio access network. You'll deal a little bit with that in looking at what your hazards are in those areas. But FirstNet is going to be obviously intimately involved in all those pieces. Anything you want?
Yeah, so this will be, mostly you'll be negotiating, I suspect, with FirstNet on the radio access network. Where are sites going to be? Are they located in places that give coverage to your first responders and the capacity they need? You may get involved a little bit with the core network. Like I said, if you've got packet data networks or data networks that you're running your public safety applications over, you would want the FirstNet core pieces to be co-located with those, so that you don't have a lot of latency in terms of data transfer. You're not dealing with a lot of backhaul costs, but primarily most of it will be in the radio access network, where the site's actually going to be placed to meet your coverage and capacity requirements. Does that make sense, or
How technical do you want us or Rob to get on some of this?
if I start getting technical, just go like this. Just bring it up. What I'm going to try to do later on when we talk about the coverage and design is I'll try to go into a little bit of the detail of it, but it's really more some of the parameters that you should be looking for and some of the type of values. Like when you get, because as Kim was saying, you're collecting a lot of data now. The data is going to go into FirstNet. FirstNet's going to release their comprehensive network RFP early next year, and they need to have all this information from all the states so they know kind of what's the whole volume of really devices that they're looking at, so that when they negotiate with a carrier or an infrastructure partner, they can give them an idea of how big the network's going to be, how many users, how many devices. But then what's going to come out of that is probably, and I'm just guessing, maybe 2017, they're going to be bringing you state plans, which are going to be, okay, you gave us your coverage and capacity requirements. And based on the agreement we've done with our RFP winners, which could be a nationwide carrier, could be content providers, we don't know. Here's where we're planning on putting your sites, and here's how it's going to be designed. But you're going to want to look for some certain values and parameters with that, like a signal to interference to noise ratio, capacity and coverage plots showing cell edge throughput. Is this the kind of throughput that you want in that area? So I'm going to try not to go too much into detail, but I'll try to keep it at a high level. But if you can, I'll point out certain values or parameters or concepts that just keep in the back of your mind and hold on to these. Because if you're part of the review with Kim and others of these state plans coming from FirstNet, you're going to want to ask them, well, what about this? What about that? Have some idea of the questions to ask them during the negotiation.
And so let's take a walk back and just talk about the difference between LMR and LTE, because there's a significant difference in many aspects, but it is not a one-to-one changeover, or transfer. So if you're using LMR now, using your radio, you go to a certain location, you have coverage there, you can put 20 people in that area and still have the same coverage. Push to talk, unless you're walking at each other and pushing to talk at the same time, you're going to have coverage. LTE is different.
So let me just say, this slide and the next one aren't in your handouts because we were talking to Kim and she had said, it might be good to do some LMR comparisons. So we'll have a PDF of the final one, and you'll get a copy of it. So sorry, you don't have this slide, the next one in your presentation.
Yeah, go ahead.
No, I just wanted to say that. No, continue.
No.
Oh, you want to? Okay. So I've been doing commercial wireless for about 20 years. I'm not an LMR expert, but I know that LMR designs are pretty much done to give you kind of a static and guaranteed coverage area for delivered audio quality or some kind of kilobits per second. In LTE, you've got this 10 megahertz channel, and you have different sectors, and you're giving people data uplink and downlink at the same time at the same frequency. So you're sharing the same quote-unquote channel at the same time. Do you know what the concept of a sector is? If you've got a cell site and you've got 3 sectors, each covering 120 degrees, within each of those sectors, you're using the same, actually in all of the sectors, you're using the same channel at the same time, and all the adjacent sites as well. So, okay. So LMR's got this kind of static coverage area where you've got a certain delivered audio quality, and you're all having your own different channels inside of that. With LTE, in each of these sectors, you've got the same frequency and at the same time. And what happens is you get farther away from the site here. To my understanding, you're going to get a delivered audio quality here. It's going to be similar to the delivered audio quality you get at the cell edge. With LTE, it's much different because LTE is very efficiently using these time and frequency resources. So what happens is you go farther out here, you start dropping in capacity. Now, you'll have very high capacity here towards the center of the cell, but as you start moving out, you'll start dropping capacity. And what happens is that if you start adding, you want to go ahead and, if you start adding users into that sector 1 there, you start slicing up the available capacity of throughput that you have in that sector. Now, for 10 megahertz, the theoretical peak data is going to be 150 megabits on the downlink, okay? But you're never going to see that. That would be an ideal situation. You're the only user on the cell. You're sitting right underneath the cell site. You've got no adjacent sites around you. You have what they call a Category 5 device, which can do different spatial multiplexing, can do very high modulation schemes. You're probably going to see something, and I'll show you some of the designs that we did, you know, somewhere maybe 25 to 40 megabits actually on the downlink. But all of that has to be shared amongst a lot of different users, and they're doing different applications. Some are doing video, some are doing texting, some may be doing a multi-call, and they're all going to be sliced up differently, but they all have to use that same resource. Now, another thing, because all of these sectors are using the same frequency channel, you can't load up all these sectors 100%, right? Because if you get in between these sectors, or you've got adjacent cell sites here, they're going to start interfering with each other, right? Because they're all using the same frequency at the same time. So the point here is that unlike LMR, where you go in these areas and you're pretty much guaranteed a certain, you can expect a certain delivered audio quality or a certain capacity. In LTE, it very much depends on where you are in the cell site, how many other users are around you. Because what are other users doing to you? They're causing you interference because you're all using the same resource. So does that make sense, or is there any questions about that?
So from an operational perspective, you put 100 responders in this coverage area, they're all going to be able to access that network, assuming they're not walking on each other. Put 100 responders in a very small area here, they're all going to be sharing that spectrum, and it's going to limit how much data they're going to be able to access. You get 100 officers here who are all trying to access live video, that's going to be a problem. There's not enough spectrum, there's not enough capability to go around for everybody to get for everybody to access the type of data they want. So it is very different. Now, keep in mind, LMR is voice, it's not data, but it does change the way operationally you think about coverage. And ultimately, it'll come down to when you know you have places that have a lot of responders in one area, you need to augment the system, or FirstNet would need to augment the system to provide that coverage. Yes, go ahead. Yes, that's on the LTE side. Okay, the first thing I did is I walked over to the LMR side and I said, you have 100 users here, and I'm just using 100 as just an example. But you have 100 users on the LMR side, and they're all going to be providing basically the same coverage and the same access. But you put those same number of users who are demanding different types of data on an LTE network, and they're limited in what they can do based on what their demands are and the throughput they have. Rob, you want to expand on that at all?
Yeah, so yeah, the hundreds, was just an example, but yeah, you would assume the 100 are spaced at different areas within that sector. So you might have some in the dark green, which means they're getting a higher modulation scheme or higher throughput. Some of them will be in the medium green, so they're at a lower modulation scheme, so their throughput decreases, and then some will be at the very light green, which is at the cell edge. And at the cell edge is in LTE where you really start to tax the resources of the cell. And we'll get into this in some slides later on, but you usually design coverage in LTE down to a minimum cell edge throughput on the uplink and downlink, and that's usually somewhere, 768 kilobits per second, 1 megabit per second, 2 megabits per second. But in that scenario, you can think of the orange dot there in sector 1. If this sector was designed for a minimum downlink throughput of say 1 megabit per second, that one user, that one orange user, if they had a video stream that they were looking at, 1 megabit per second, they would be using all the resources in that sector. So all those different colors you see in the LTE spectrum bar, those would all go to orange if that user was the only user in that cell and they were doing, say, 1 megabit per second, if that's what the cell edge was designed for. So the thing in LTE to keep in mind is that there's different modulation schemes, and it's dynamically changing the throughput that each user gets based on where they are in the cell and what type of application they're trying to do. And if you're towards the edge of the cell and you're trying to do a very high capacity video uplink, you may not be able to do it, and you would have to move closer to the cell. Now, the one thing that affects all of this are priority mechanisms that we'll get into a little bit later, but this is assuming you're treating every user equally and you're trying to serve them with those resources. Does that make sense? Or okay.
So Rob, I'm going to let you talk through the deployment solutions, and I'll chime in some operational pieces. So there are 5 key deployment solutions for LTE. The 3 on the right here are fixed, small cells, macro cells, and boomer sites, and then the 2 on this side are deployable solutions, which are either on-net deployable solution or an off-net deployable solution. I'll let you go through the details of each.
Okay, so can you hear me on the conference bridge? Okay, sorry, I was stepping away a little bit from the computer. So if we look at the far right, typically most of the population is concentrated in dense urban and suburban areas. So usually now capacity in LTE networks, which is very similar to other wireless technologies, is really based on the bandwidth that you have, which we know is fixed. It's 10 megahertz up and 10 megahertz down. The cell spectral efficiency, or how many bits per hertz you can get out of each cell site, and the number of cells. So the 10 megahertz is limited. We can only get so many bits per hertz out of the cell, depending on how good the cell vendor is. So what we have to start doing is increasing the number of sites in a given area. So we know in dense urban and suburban areas, we have small cells, picocells, femto cells, very small cells, which are trying to concentrate more and more capacity in a much smaller area because the population density is much greater. And these are going to be typically fixed cell sites, small cells going on light poles or indoor distributed antenna systems. Or, they could be deployables, which might be brought in for a special event or for an emergency in an urban area to even have. It starts decreasing, and we start going out into suburban and kind of the outer parts of the city. You'll start getting into macro cell sites, which are bigger sites. They're covering a much wider area because there's simply not as many people in that given area. So the cell sites start spreading out apart from each other because you just don't have the density of population, you don't have the capacity. So you get out to macro cells, it could be 1 to 10 miles. You could also have in urban and suburban areas, you could have macro cells providing capacity as kind of like an umbrella on one frequency band, and then small cells sitting underneath them providing even more capacity at a different frequency band. But for the frequency that we have with for example, FirstNet, we've got one frequency. So you have to be very careful managing macro cells and small cells to avoid interfering with each other. As we go farther out in the rural area, we start getting into these more boomer sites, which I think are more typical like LMR sites. They're up on high places. They cover a very wide area, 10 to 25 miles. They could cover 50 miles. I've seen a lot of the LMR plots here in Utah